a majestic star-forming region of the Eagle Nebula. A stunning view of a spiral galaxy. These incredible pictures were produced by Hubble, the highly successful space telescope. With no atmospheric distortion to overcome, it can easily see objects millions of light years away. This April 2008, it celebrated 18 years in orbit.
It's really been, I think, much more successful than anyone would really have anticipated. In fact, I think it's true to say that it's revolutionized astronomy. It enabled views to be obtained of the very distant universe, unglimpsed, unthought of when Hubble was launched. These big telescopes that look back, I mean, they're really time machines. In fact, I think it's an amazing intellectual concept that you can take a telescope, you can look very deep, you can take very long exposures, and you can look back to the early history of the universe. At one moment, we're looking back, 13 billion years, and the next moment, we're looking at our neighborhood, and we're finding out what all of that turned into.
Hubble orbits the planet 600 kilometers above the Earth, and although it's close enough to have been serviced and upgraded 4 times, the 5th and final tune-up is scheduled for October. After this, it should be in fit working order for another 5 years. During its working life, Hubble has taught us an enormous amount about the early formation of stars and galaxies, but because it's an optical telescope that works in wavelengths visible to the human eye, its scope is limited.
We have a big gap in our understanding because we can study the structure of the very early universe shortly after the Big Bang using missions like COBE and the soon-to-be launched ESA Planck mission, and we can study galaxies with Hubble, but the two don't yet match up.
Hubble's successor, the JWST, should help bridge that gap. Named after the boss of NASA's Apollo program of the 60s, the James Webb Space Telescope uses infrared to see through clouds of dust to distant objects whose light has shifted to the red end of the spectrum. To pick up infrared radiation, JWST has to be in a cool, dark spot 1.5 million kilometers from Earth. It operates at minus 240 degrees centigrade.
It needs to be so cold because infrared radiation is heat radiation, and so you're trying to measure the heat that's coming from very cold bodies in space, and the telescope has to be colder than the thing you're trying to measure, otherwise the signal that you would see is just the warmth of the telescope itself.
JWST will carry 4 instruments, 2 of which are being built in Europe. At laboratories near Oxford in England, they're testing part of the telescope known as MIRI, a mid-infrared camera and spectrograph. This is a hugely sensitive device that should allow for some groundbreaking scientific work by taking very deep images of galaxies and looking for debris disks and planets near stars. MIRI is also able to detect some of the chemical elements of objects such as methane and carbon chemistry in the planets and debris disks around young stars. On the outskirts of Munich in Germany, MIRI's big brother, NIRSPEC, a near-infrared spectrograph, is being built.
A spectrograph means it records the light from the stellar objects, and by this gives the scientists diagnostic methods to find out what the object is made of, and this is the prime vehicle to investigate new objects, stars, galaxies.
JWST, with its massive 6.5-meter mirror and sun shield the size of a tennis court, is the largest and most complex space probe ever built. Soon after launch in 2013, it'll begin unraveling the mysteries of the beginnings of the universe.
It's understood in broad terms, the history. You start off with the Big Bang, you produce this big fireball, which expands and expands and expands, and at some point, this fireball becomes transparent. And at some point, things started to happen. Either black holes started to form, or the first stars started to form. And at some point, one of these objects, whatever it was, started to radiate. And first light in the universe after the Big Bang. And this is the thing that is being aimed for.
It's predicted that we're only a decade or 2 from uncovering the origins of the universe. The new James Webb Space Telescope could help bring that discovery even closer.